For number 27, we're going to graph a rational function. And if you look on page 367, it's in section 3.5, there's a chart with 7 steps for how to graph a rational function. And I'm just going to go through those steps. You want to start off by finding the vertical asymptotes. And you do that by setting the denominator equal to 0. So the values that would make the denominator equal to 0 are x equals -5 and x equals -1. So the graph cannot exist at -5 and it cannot exist at -1 because we cannot divide by 0. So we'll have vertical asymptotes there. The graph will not exist. Step 2, we want to find horizontal asymptotes. And for our particular function here, our numerator has a degree of 1, and our denominator, if you would multiply this out, has x squared, so a degree of 2. And since the denominator is bigger, we're going to have an asymptote of y equals 0 for our horizontal asymptote. And that's just the x-axis. It's going to be a horizontal asymptote. Now it's nice to just get a couple of points and start plotting them on your graph. We want to start with the intercepts. So to find the y-intercept, that's when x equals 0. So we're going to plug a 0 into the function, and you're going to get 0 over 5, and 0 divided by 5 equals 0. So if x equals 0, y ends up being 0 too, so that is our y-intercept. For our x-intercept, we want to start off with y equal to 0. So 0 equals the function, and now let's solve for x. Multiply both sides by x plus 5 and by x plus 1. They'll cancel out over here. 0 multiplied by anything stays 0. So we basically multiply by the denominator, and we get to this step. And now divide both sides by 4. 0 stays the same, and we're just left with x. So we find our only x-intercept is also 0, 0. So now we want to ask, will our graph ever intersect the horizontal asymptote? Sometimes they do, sometimes they don't. And to solve for that, we set our function equal to what our horizontal asymptote was. And our asymptote was just 0, so we set it equal to 0. And we already solved this out. That's exactly what I did right here. The answer we got for x was 0. So what that tells us is the graph will intersect the horizontal asymptote when x is 0. So at our origin here, 0, 0 is the only time we're going to cross the horizontal asymptote. So now what you want to do is to look at the sections of the graph that are split up by these vertical asymptotes and plot a few points in those sections, and then you can draw a rough sketch of the graph. So let's look on this far left section. I just picked a couple points. Here they are. Picked f equals -10, and the result here is -40 over 45, which is almost -1. So we're going to have a point right here at almost -1. And then at -6 for x, we get this value, which is almost -5. So we're going to have a point here at almost -5. So if you connect those dots with a smooth curve, and then you know the graph is going to get closer and closer and closer to the vertical asymptote, but never touch it. So that lets you continue drawing it this way. And then going this way, you know what the horizontal asymptote is. It's the x-axis. So the graph's going to get closer to that, and it's never going to touch it or cross it, because remember we solved that the only place it touches or crosses it is at the origin 0, 0. So that gives us the shape of that section of the graph. And then in between the two asymptotes, again, pick a few values. So for -4, I plugged in here. I plugged it in and got an answer 16 over 3. That's pretty close to 5. So -4, you get a dot there. You plug in a -2, you get this value, which is a little bit more than 2. So you plot that point. So then you have those 2 points and then use what you know about asymptotes to complete the sketch. So you know the graph gets closer and closer to the vertical asymptotes. And we know we can't start down here because the graph, again, only intersects the horizontal asymptote at 0, 0. So if we started down here, we couldn't get up to those points without crossing that horizontal asymptote, which we know does not happen. So we have to start above the x-axis. So we would be close to that vertical asymptote, and then go through those 2 points that you plotted. So go to that point, connect to another point, and you know it has to start curving back up because once again it can't excuse me, it can't continue to go downward because again it would have to cross the x-axis, which we know only happens at 0, 0. So yeah, it has to curve back up to get closer and closer to this other vertical asymptote. And then on the right side of the graph, we already have the point 0, 0. Pick a couple another points. I just picked a couple here. You would draw them and then again complete your sketch. So close to the asymptote, it goes through the point you plotted. It goes through the origin. It goes through the other point you plotted. So you're above the x-axis now just a little bit. But you know that the horizontal asymptote is y equals 0. It's the x-axis. So the graph has to kind of stop going up and come back down and get closer and closer to the x-axis.